So today is the Sunday, right after the first quiz, so 2 days after the quiz. I told you I would start doing, and I'll try to get these up before quizzes, but I've never done it before, so this one's late. I'm going to start doing a video of all the practice problems I assign with the solutions, like I'll work the problems out basically, or give you the answers. I will also make available the answers in class, which you can just take a picture of. But then the issue with that we said in class is that you may not understand how they got the answer. So you can check your answers, but if you got it wrong, you may not understand why you're getting it wrong. So that's why I said I'd do these videos. Now, to get the most out of this, if you really want to do well in your class, don't just sit here and copy stuff down. That's not going to do you any good. At times, I might tell you to pause and think about something. So pause and think about it. Or I might tell you to now try to figure, the next problem out if they're related. So pause the video and try to figure it out. If you're just sitting here and watching the video and watching me go through it and maybe copying it down after the fact, it's not really going to help you that much. All right. And oh, that's it. All right. So if you weren't there, we showed it a million times in class, so you should know what the assignment was. But the assignment was page 11. So that's the page that this is on, 1 through 19 and 25, I believe 25 through 31. I'm doing it from memory. Again, if you need to rewind, I'm going to go really fast. So if I write something up, you can go back and pause it if you need to write it down if you didn't have that already. Should have had that already. In blue. First question, name the lines that are only in plain Q. So again, I've graded some papers and I have marked a lot of stuff wrong that you guys probably think you got right because you weren't detailed, you weren't specific. It says name the lines and it's plural, so it's multiple lines and only in plain Q. So plain Q. Now, and this was not the same question as on your quiz. So I'll try to relate it to what kids did on the quiz. There we go. So first of all, if it's on plain Q, I got to find plain Q. I think most of you are probably good there. So that's plain Q. It says name the lines. Well, and if it says in the plane, that also means they are coplanar. So we'll talk more about that in another question. So this particular line here is in the shaded region. That means it's on the plane or in the plane. Part of the plane really is maybe even a better description. And that line right there is in the shaded region. We said in a two-dimensional image, so a picture basically, the way you know that either a point or a line in this case is in the plane or is part of the plane is as if it's in the shaded region. We consider it part. So just as a quick example, that is not part of this plane. That is not part of plane Q. None of these are part of plane Q either. They're in a different shaded region. So only the things that are in this shaded region are in plane Q. And everything is really driven by points because a line is made up of points. So unless I guess maybe you could consider, that's not really points. And we'll talk about that more later also. Let's try to go over all the mistakes already that I've seen. So if I wanted to name it, it does not say name it every way possible. Some of you try to do multiple names in a question like this on the quiz, but what you do have to do is name it correctly. And this is one of the things I took off for right here. If you just said in like that, that is wrong. You just said Q, that is wrong. If you just said LH, that is wrong. That is not how we name lines. If it says specifically name, you had to name it correctly. You just needed one correct name. So line in, which is really the only way to name this one. There's only one point, so I don't have any other options. So you had to write line, or you would have to write line in. Again, this was not your quiz question, so I didn't have one with just one point on it. You could also write line Q. Oops. For the other line, Why is that not working? There we go. Or that one has two, actually three options, because you could write LH and then you would need the symbol, or you would need to write the word line in front of it. And you could have also done HL. Again, you need the symbol or you need the line. So those are the two lines. So again, knowing which lines was part of the answer, but also being able to name them correctly was part of the answer. How many planes are labeled in the figure? Again, that's just knowing what a plane is. Hopefully, I don't think many people would miss that for this particular problem. It's two. We have one plane here, one plane. Name the plane containing. Again, it says name, so you have to correctly name it, not just write a letter or something like that. So first you got to find the lines. Well, that right there is M. That right there is T. Which shaded region are they in? Well, obviously they're in the shaded region here. So how do I name that? Again, doesn't say every way possible. So I would just use the one letter, and you would have to write plane before it, or I would mark it wrong. And I'll tell you why. There was a question where that really comes into play. It's coming up in a second. So yes, you would have to write plain R. Or you could use any 3 points that can make a triangle and name it with those. I'm not going to do all of them, but if you said, okay, well, I know it's this plane, I'm going to use these 3 points. You could write plane. Any combination would work. Any order, I mean, B, C, E. But that would also be fine. And there's a few other options you could have used. Again, I'm going to go fast. Pause it. Go back and watch it again. Slow it down to 0.75 speed if you need to. Name the plane. Oh, I just did that one. Name the intersection. All right, here is the one where you're really going to think it's picky. Name the intersection of lines MT. Well, there's M, there's T, X, or not X, but the point where they cross is the intersection. We did this in class where we said anytime two lines intersect, they intersect in a point. So the answer is that they're going to intersect in a point, but, and nobody really so far just wrote point, it says name that intersection. Here's what a ton of people did that I marked wrong. They wrote a C. I don't know why my little pen's not working. I marked it wrong. Now, I give partial credit on quizzes, so you get some points from me seeing that you understand where the intersection is. But here's the issue with that. I don't know if you understand that's a point if you only write the letter C. You may think that's a really small nitpicky thing, but I had people write line C, even though it was a capital letter, even though it's not a line. You have to be specific. I need you to be specific. I need to know that you understand the material. And we'll get to explanation point or questions. I am very, very picky about those because I need to know you understand it. You can't just repeat what's in the question in a different way that doesn't show understanding. So in order to get full credit for that, you had to say point C, capital C. Can't really tell mine was capital, but that's because it says name. Let's see. Name a point that is not coplanar with points A, B, and C. All right, so first thing you need to know is what does coplanar mean? We said that means part of the same plane. How do you identify that? We said, well, in the same shaded region. So I need to find out where A, B, and C are. Well, they're not in the bottom plane. Oh, there we go. A, B, C. So what other point is part of that plane? What other point is in that same shaded area? There's actually a couple of options that I could use. M is not a point. R is not a point. D is a point, but it's not in the shaded region, so I can't use that. So F and E are my only two options. It does say name them, so again, I need to write it correctly. Point F would be an answer. Why is this not working? There we go. And then point E would also be an answer. But you have to write point or else you lose points. Or point E. Next question, are points F, M, G, P coplanar? All right, so I'm going to spend a second on this. So a lot of people got confused on a couple of different things here. Some people said something about a triangle. Whether or not they're in a triangle has absolutely nothing to do with whether they're coplanar. You could not be able to form a triangle and they're still coplanar. You just can't use them to name. I forget exactly what kids said. I don't know if they said the answer to that the quiz question was no or yes, but they said something about, being able to form a triangle. Again, being able to form a triangle just means you can use them to name. It has nothing to do with coplanar. I mean, they might be coplanar. They would actually have to be coplanar to use them to name. But again, on the quiz question, some kids got that confused. Just because I'm not going to tell you the specific answer to the quiz question, so I don't want to keep saying stuff. So here I'm going to draw in, actually, no, let's just do this. So this line up here, let's say we put a point. That point right there I don't see an S, so we'll call it point S. Let me see if I can, I don't, no, I cannot zoom in. So point S, it's not a 5, that is an S. Point S. Point S is on the same line with C and E. All that means is I cannot use those 3 points to name the plane. But they're still coplanar. They are in the shaded region together, so they are coplanar. Again, this is not part of this question, so I hope I'm not confusing you. I'm talking more to the quiz when I'm doing this one. So if you need to go back and watch the lesson from that day, understand that being able to form a triangle just has to do with naming. You can be on the same line, just like the ones I just circled, S, E, C. You can be on the same line and be coplanar. You just can't use those particular points to name the plane. All right, so I spent more time than I meant to on that. So are these 4 points? So we got to find the 4 points. So there we go. Looks like we're down here. So far, so good. F, M, G, P. Where is F? Oh, F is up here. F, M. Oh, it's not. All right. So I think most people would say, no, those are not coplanar. They are coplanar, meaning they are part of the same plane. I'm pretty sure, I hope, most people would say no. But then most people would also struggle to truly explain that. I know this is an English class, but sometimes the only way I know you really understand something is if you can explain it. So you've got to work at your explanations. And I gave you one in class if you were really engaged. That all you got to do is write, if you need to explain coplanar or not coplanar, they're in the same shaded region if they're coplanar. Well, these 2 points down here are in this shaded region. So those 2 points, G and P, point G, point P, those are in that shaded region. They are coplanar. Point M is not inside the shaded region. It is just above that shaded region. So it is not coplanar. Point F is in a different shaded region. So it is not coplanar with these 2. It's coplanar with all of these, but it is not coplanar with G and point P. So the answer would be no, they are not coplanar. And then I would accept, here's what you cannot say that a lot of people said. You cannot say they are not part of the same plane. That doesn't explain to me how you know it. You're just telling me a definition for coplanar. You need to explain to me how you know they are not part of the same plane. You really can almost never use the same word to explain something. So if coplanar or planar is in there, you can't use the word plane in your explanation. You gotta describe it a different way. And again, in this case, you just say no, they are not all in the same shaded region. All right. I'm not going to do all of these. We kind of went over them, I believe, the day of the quiz. I think we were. What just happened? Oh, maybe it was doing that. No, it shouldn't have. So I told you there were some real world examples. We might have even gone over some of these. If it is a flat surface, then it is a plane. So panels, if you're not sure what a panel is, it's these, oh, I gotta change my pen. It's these rectangular things. That's a panel. Those are planes. A tabletop is a flat. Now, it does not have to be in the shape of a rectangle or a square. We kind of went over that. Like, you could really say that the plate is also a plane, is sort of a flat surface. Not really, but so just remember a flat surface. A beam is rounded normally, so you wouldn't really say it's a plane because it has a curved kind of outside, like think of a can. So it's more of a line. So again, I'm not looking at the book answers. I'm assuming that's what they said though. The chessboard, again, that's definitely a plane. I'm not even sure what part of this they're talking about. This number 12, we kind of went over it in class. I would guess they're talking about these rectangles. A rectangle is a plane. If you slice a curved object, that's a cylinder. If you remember what a cylinder is, you slice it, then you have a plane as a flat surface after you slice it. But the original cylinder, you could not say as a plane. The top of a cylinder could be a plane. Like if we had a cup, that's not a good example. Let's go back to a can. If we had a can, the top of the can is flat. So the top of it is a plane. Number 13, I would guess they're saying this is a point and they're talking about the knot. They don't really explain that. But if you thought that it was the knot, then it's a point. If you thought they meant the whole string, then it's a line. And I'm not even going to go over the rest of them, but hopefully you get the point. No pun intended. I was trying to think of a way to say that. Oh boy, this is a really tricky way to do when I'm doing this from home. It's really tricky to do it. So now we need to do, oh, wait, where's 20? Oh, I know where they are. Yeah, we gotta go back over there. All right, here we go. 21 through 35 is what I said. Maybe. Oh no, 25 through 31. Sorry. I already did this video. What am I thinking? Or did I? I don't know. I'll go back and look and I'll post the better video. But I feel like I'm going back over this again. How many planes are shown in the figure? A lot of people missed this, especially when there was an explain question as part of it, which will be number 28. A plane is a flat surface. That's all you got to look for. There's only one thing you got to kind of figure out that I would say is a little bit higher level than just looking for a flat surface. Now, visually, it can be difficult. Hopefully, you see that flat plane there. There's one. That's a flat plane there. That's two. That's a flat plane there. That's three. Then, though, there's a plane in the back that you can't really see. It's made up of points F, A, C, and D. There's that plane back in the back. It's a little trickier to see. But I also told you if you have a vertical object that's kind of attached to a plane, just look at the base. That'll tell you how many planes are going up vertically. If there's three sides in that object, basically it's the base of the object, and there are three sides of this, then you have three planes going vertically. If there's four sides of the base, then you have four planes. And it doesn't have to be like this, it could be all going up into one point, and you would still have three planes. You can have a triangular plane, like this side here is a triangular shape, but it's a plane. It's a flat surface. So we have the three going up, the one on top, We know we have this big one here. So really the only question is, we did this in class, do I count this flat surface that's the bottom of that shape again? And we said, no, we don't. I should have asked you to think about that, but those points for this base have already been counted in this orange area. When we count the orange shaded area, it includes this shaded, hold on. It includes this shaded right here. We already counted those points once when we counted the big orange area. They're sharing those points. It's not a separate thing. So we said, no, we do not count that again. So the answer would be 3 going vertically, 1 on top, and then the one big orange sort of rectangular plane. So the total for that would be 5. That's question number 25. How many of the planes contains point F and E? That one's a pretty good question. I like that question. Wasn't one specifically like that on the quiz, but there was one where if you understood this, you'd be good. So here's F and E. Really quickly, the corners of a plane are part of the plane. They're coplanar. They're part of that plane if they're corners. All of the points on a line that makes up a plane. So these lines that I'm drawing, any point that is on those lines is part of the plane. It may not be in the shaded region, but it's touching the shaded region. It's like it's part of the plane. So again, corners that are points or lines that are edges are part of the plane. So you need to understand that because that was one a lot of people missed and they didn't know how to explain it as well. You can just say corners of a plane are part of the plane. Lines that are edges of a plane, like BC, is the edge of this plane right here. So it is that line DC is coplanar with the plane that I just showed it in. We can name it plane EDC. So we're trying to figure out how many planes. So which flat surfaces are these 2 points corners of? That's really all you got to, and they have to both be corners, not just one of them. Well, it's definitely a corner of his, right? It's part of that triangle. So there's one plane that includes it. It's definitely corners of this rectangle here. Both of them are corners, so it's definitely part of that one. So that's 2. It is not, and again, they both have to be corners. They are not corners of this plane here because F doesn't touch any of that blue that I just used. Obviously, they're not corners of anything down here because neither of them touch that. So the only other maybe question is if you kind of look at the plane that's in the back, and this one could be tricky to imagine for some of you. That plane, again, is way in the back. E is not it's not in a shaded region of that plane. Even though it's in the middle of the rectangle I just drew, E is like closer to us than that blue rectangle. Hard to show 3 dimensions in a picture. So E is not technically in that shaded region that I just outlined. It would be closer to us than that region. So it would not be part of that. That's the one that I see as being tricky. So the only 2 that they're part of are the top triangle and then this rectangle right here. So the answer is that. Name 4 points that are coplanar. Again, just any 4 points that are in the same exact shaded region. They could be corners of the region. So you could say these 4 here because they're corners of that rectangle there. You could say these 4 here, they're corners of that rectangle. Or you could say these 4 here because they're corners of that back rectangle that we can't really see. So any of those would be answers. I think that's the only answers though. So if you thought something else was, isn't. And then last, are points A, B, and C coplanar? So I'm going to give you a chance to think about that. That's a pretty easy one. I wish they would have done a more difficult one. So yes, they are coplanar. Here they are. They're actually just coplanar with each other because they're part of that base of that shape that's going up vertically. But you could, so you could just say that, yeah, they're the corners of that triangle, the corners of that base. Or you could say, well, yeah, they're coplanar because they're all in the shaded region, the orange shaded region, or I would probably be fine with just the shaded region as well. So that was easier than the quiz question. So just know that. So make sure you understand all the other ones that I went over. And I know I already did this video. I can just remember doing it because I said don't worry too much about one of these upcoming, but there. Building, again, kind of like that other thing. Oh, actually, no, this isn't like the other thing. This has to do with intersections. So again, in class, we had some rules. Two lines intersect in a point. Oops, didn't mean to do that. Two lines intersect in a point. Right there, that would be the point. A line into plane. So kind of hard to draw, but we said if a line goes through a plane, it only touches that plane at one point. So we said there's no exceptions. A line intersects a plane at one single point. And then the last thing was we said two planes, only two, intersect in a line. And I did that thing with the cardboard. I'm not even going to try to draw that. But that's what this question is about. So if you see two planes that intersect, they have to form a line. So for example, this side of the house is a plane. It intersects with that section of the roof. So this BH right here is a line. The roof and the house touch at a string of points that are all in a row. Line BH. So that's what you're doing in this one. And you have to imagine a little bit about how a house would look in real life. So again, this rectangle, that side of the house, intersects with this side of the house. Well, obviously they intersect at that line. A has nothing to do with that. They only intersect right where this thicker blue line is, right there. Actually, here, let's do this. They only intersect there. They don't intersect anywhere above that, even though it kind of looks like it's going up. You know what a house looks like and how a roof slants away from the edge of the house. So that's how you do that one. It does say name all of the lines. So if you need to know how to, I'm mostly doing explanations, but the roof intersects in a bunch of lines, AG, AH. And again, there you could have named them with the letters in different orders. BA. Take a picture of the answers in the room. I'm not going to go through every single one of these. There's other GH is also an answer for the roof. There's actually another line in the back, but we can't see what the point would be. Like there's a corner that would be the opposite corner of H. Well, we can't see it. We don't know what letter that would be, so we can't name that. But there is another one in the back, so just know there's actually another one. HD would be a line for the house. DC would be a line, I'm sorry, for the walls of the house. FE would be a line for the walls of the house. These would not be answers. And again, if you just wrote every single line, you would be wrong. This is not a line formed by an intersection of the house itself. This is not a line formed by the intersection of the house. So those would be wrong. They only wanted to know where the intersections of the planes of the house form lines. So those would be, DE is a line, it's just not formed by any intersections. So a little bit of a tricky thing. There wasn't one on the quiz that don't look like that. I'm sure you'll see it on district stuff or even state stuff. So hopefully you know a lake is a plane. It's a flat surface. If you drop a straight line or put a straight line through a plane, it intersects in a point. So wherever it hits, say it hits right there, that would be a point. We kind of talked about the intersection of a line and a plane already. And then I went over this in the other video. I'm not even going to go over it here. It's just, this is a tricky one. You do need to understand there are planes in this figure, right? It's a drawing of kind of like a city block, and it's supposed to sort of show you three dimensions as it goes away from you. The perspective is supposed to get smaller. If you're into drawing, you might want to kind of look at this a little bit more than other people that aren't into drawing. But as you get away from this front side right here, anything that's closer to you would look bigger. So as you get away, they just change the dimensions and they start making things smaller. If you'll notice, all of that stuff kind of gets smaller as a straight line. Like that line is parallel to that sort of, and that's parallel to that. That's what makes it look like it's getting smaller. If you take art class, they might cover stuff like that. So you guys wonder why you need to know math, geometry. Well, if you like to draw, it comes up in drawing a lot, especially when we get to scale and scale factor stuff. I think we do that in geometry. But yeah, I'm not going to worry about you knowing that for the quiz. Just it's kind of similar to what we just did with the house above. So again, lines, it says, where do the lines intersect? That has to be point, because then lines can only intersect in a point. The vanishing point specifically. And then planes would just be any flat surface, so the sides of the buildings, or you could even say the sidewalk, even though it's not actually a rectangle. Because again, just make sure you understand, planes do not have to be rectangles. They can be weird shaped triangles, circles, anything that is flat. So that's everything. If you have questions, if you need more answers or something and you just need to take a picture, ask me and I'll get the book out and find the page and take pictures of the answers.